Now we're going to sketch a graph of the piecewise defined function. Just as we did before, with evaluation, we have to consider the domain. What might be a good idea is to draw the entire thing and then erase what you don't want. What I mean by that is the first piece, which I'm going to do in purple. It's not going to turn out very well, but I'll do my best. The first one is the line y equals 2x minus 3. Y equals 2x minus 3, well, is a line that has a y-intercept at 3. Let me plot that real quick. And a slope of 2, so up 2 over 1, so right there. So if I attempt to draw the line, oh, that's so awful. Oh no. Oh no. You can't tell because of editing, but this is like literally my third attempt at this. Oh, that's just terrible. All right, pretend that that's a line. There were several earthquakes as I was drawing that. Okay, we want this line only when x is less than or equal to -2. Well, here's -2. Less than or equal to means to the left. So on our graph here, we don't want anything to the right of -2. So I'm going to erase out the stuff to the right of -2. So it mostly looks like a line there. But because there is an equal sign underneath this inequality, we will close off this graph with a closed dot. I couldn't even do that correctly, but that's okay. Hopefully you get the idea. All right, the next one, I'll do that one in blue, is the line y equals 5. This is a constant function. No matter what x is, y is always 5. You might already know that this creates a horizontal line. Oh, I'm doing much better with this one. Much better. All right, Tina Belcher. Anyways, we only want this line to exist from between -2 and +1. So anything outside of that area we don't want. So I'm going to erase everything to the left of -2 this time and to the right of 1. Looking at the inequality, notice neither of them have an equal sign. So when we finish off the graph, we use an open circle. By the way, I just noticed counting is hard. I made the circle. I made it go too far. Hopefully you caught that. And I would love to say that I did that on purpose, but what I did in my head was I checked it. Remember, we're drawing a function here, so it has to pass the vertical line test. And what I had did not pass the vertical line test because I could have picked the line x equals -2.5. And that would have went through both pieces. You can't go through two pieces at one time because then it wouldn't be a function. So I learned something. Always use the vertical line test anytime you have to graph a function. The last one I'm going to do in green. You should already know that x squared is a U-shaped curve. That was pretty. And the -4 says move down 4. So if I had a full parabola, something like this. Oh, that is terrible. That is so terrible. Move down 4, we'd have that graph, but we only want this to exist for x values bigger than or equal to 1. So to the left of 1, I'm going to get rid of stuff. Oh, don't erase the purple. Oh, I erased the purple. Oh my gosh, what a world, what a world. All right, let me put the purple back in there. And then at 1 for this for the parabola, what type of dot am I going to use? Hopefully you set a closed dot because it's got an equal sign. So a piecewise defined function, again, is made up of pieces of other functions. Hopefully yours looks 20 times better than this one, because this is terrible. Absolutely terrible. I'm sorry, Picasso.